Hi and Assalamualaikum. Welcome to our video on the moment of force. In this video, we will learn the concept of moment, also known as torque, and explore its significance in understanding rational motion. Let's start with the definition of moment of force and its unit. The moment of force is a measure of its turning point. It can be defined as the product of force and perpendicular distance from the point to the line of action of the force. Next, formula of moment of force is M equal to F times D, where F is force and the unit is Newton, D is distance and the unit is meter, and SI unit is Newton meter. Let's watch this video. In this video show that there are two factors that affect the moment of force. Number 1, increasing the force. If you keep the distance constant and increase the force applied, the moment of force will increase proportionally. Number 2, increasing the distance. If you keep the force constant and increase the perpendicular distance between the force line of action and the point of rotation, the moment of force will increase.
Next, let's have a look at example 1. The question needs you to calculate the moment of force. To solve this question, we need to use formula M equal to F times D. Then, substitute the value of F equal to 5 and D equal to 1. So, M equal to 5 times 1. And the answer is 5 Newton meter.
We move to the principle of moment of force. The principle of moment of force states that when in equilibrium, the sum of the anti-clockwise moment is equal to the sum of the anti-clockwise moment. When a system is balanced, it is said to be in equilibrium as all the forces acting on the system cancel out each other. This is formula for the principle of moment of force.
Next, let's have a look at example 2. The question needs you to determine the center of gravity for force action so that the bar remain in horizontal equilibrium. There are two methods to solve this question. Method 1, force moment method. X is the center of gravity from A. Step 1. The total of anti-clockwise moment equal to the total of clockwise moment. Step 2. Substitute to the formula for the principle of moment of force. 5x plus 8 times x minus 2 equal to 15 times 8 minus x. Then, 5x plus 8x minus 16 equal to 120 minus 15x. Then, 28x equal to 136. And the answer is x equal to 4.86 meter. Next, we use method number 2, resultant moment method. We use formula x equal to F1 D0 plus F2 D1 plus F3 times D1 plus D2 divided by F1 plus F2 plus F3. Next, substitute the value in the formula. X equal to 5 times 0 plus 8 times 2 plus 15 times 8 divided by 5 plus 8 plus 15. Then, x equal to 136 divided by 28. And the answer is x equal to 4.86 meter.
Have you ever wondered why you can push a door open or why objects falls to the ground? It's all about interaction force. From the simplest interactions to the most complex phenomena, force are at play. When we hammer a nail onto a wood, we know the hammer is exerting a force onto the nail. The striking of hammer
is downwards and exert a downward force onto the nail. The interaction force between them involves the applied force from the hammer and the reaction force from the nail.
Let's begin our learning journey. So, what do you know about interaction force? Well, it is the force applied to a beam or other structure when it rests against something. Remember, interaction force or reaction force is always there when you push or you pull something. It's like a response from the object you are interacting with. So, be careful with the forces you apply because there's always a reaction waiting for you. Reaction force are involved by applying two conditions. The first condition states that a body in equilibrium has no resultant force in any direction, which is the sum of anti-clockwise force is equal to the sum of clockwise force. The second condition states a body in equilibrium has no resultant turning moment in any direction, which is sum of moment anti-clockwise equal to the sum of moment clockwise. Let me show you one example. This example shows how to calculate reaction force on simply support beam. So in my example, I'm considering a simply support beam and there are two forces. This is our free body diagram and this is the essence in how to solve this problem. First of all, we need to comply two conditions. The first condition, the total of anti-clockwise force equal to the total of clockwise force, which is here RA plus RB equal to 16 plus 8 Newton. Then we get RA plus RB equal to 24 Newton. Make it as an equation. And let's reconsider the second condition, where the total moment anti-clockwise equal to the total moment clockwise. Then we substitute the value into the equation 1, which is RA times 0 plus RB times 8 equal to 16 times 2 plus 8 times 4. Finally, we get RB equal to 8 Newton. After that, we need to substitute the value of RB into the equation 1. And lastly, we get the value of RA equal to 16 Newton. So okay students, easy right?